Huffman. What did he go and do this time? Whoa! Check that out! Looks like he developed an ingenious system for encoding data. As for how it works, well, that's what we're gonna show you today. Alright, so what is Huffman coding? Well, first of all, Huffman coding is a lossless compression method. That means we can use it to compress a message without any data getting lost. The basic idea is that two characters with the lowest frequency or probability are given a code of the same length, and characters that appear more frequently than others have a shorter code. It's actually the same logic behind Morse code in a way. Now to understand this, have a look at this message right here. The letter A is going to have the shortest code here, since there are more A's here than any other letter. That means the code for B is going to be a little bit longer. And the codes for C and D are going to be the longest, and since these two characters have the lowest frequency, they're going to be the same length too. Yeah, but how exactly does it work? At the end of the coding process, we've got a tree that's built from the bottom up. This tree makes it possible to give each letter its own code. Let's go ahead and look at an example to see how this process works. So we've got this message right here. The first step in Huffman coding is always to figure out the probabilities for each character. The best thing to do is to make yourself a little table and write in the probability for each character. A appears 4 times. Now our message is made up of 10 characters in all. Doing the math, we get a probability of 4 out of 10, that is 0.4. Now let's do B. B appears twice, so it gets a probability of 0.2. E shows up 3 times, giving it a probability of 0.3. And since all we have is one F, we write in a probability of 0.1 for it. And now if we add up all these probabilities, we should get 1. Alright, that's it for the first step. Now we're gonna build a tree from the bottom up. All the way at the bottom, we write the characters and their probabilities. It actually doesn't matter what order you put them in here. You can make it alphabetical if you want. But since we're gonna be looking at the probabilities, it might make sense to sort them that way, starting with the most probable. So first, we write A, and below that, its probability 0.4. Then E, with a probability of 0.3. Next comes B with 0.2, and finally F with a probability of 0.1. Now we have the lowest level of our tree. Okay, now here comes the most important step in Huffman coding. We always take the two characters with the lowest probabilities and combine them. In our case, that would be B with a probability of 0.2 and F with 0.1. Now we just combine them into one node, one level up, where we put together the two characters and add up their probabilities. So, BF and 0.3. Alright, so now you know how to do this step. But we need to keep it up and combine the next set of characters with the lowest probability. This time that's going to be E with 0.3 and BF with 0.3. B and F are already off the table. Okay, when we add together the probabilities of E and BF, we get 0.6. So now we've got to do it all one more time. The only ones left are A and EBF. Add them up and we get AEBF and a probability of 1. That's what you need to end up with, all the characters combined with a probability of 1. And now our tree's finished. Sweet! But what are we supposed to do with it now? If all I wanted was a nice tree, I could have just gone to Lowe's and bought one. Well, now what we're gonna do is label the branches on our tree. Remember, what we want to do is encode the message. So we're gonna label the branches on the right with zeros and the ones on the left with ones, since we always want to have everything in binary code. As for whether you label all the left-hand branches with zeros and all the right-hand ones with ones or the other way around, it actually doesn't matter. The only thing that's really important here is that all the left-hand branches are the same and all the right-hand branches are the same. So we're gonna go ahead and label all our right-hand branches with 0. and all our left branches with 1. Now we just need to read the path it takes to get to each character, going from the top to the bottom. And that's how we get our code. To get A, we just need to use a single 1 branch. So, A has a code of 1. We can get to E by taking a 0 and a 1. So the code for E is 0, 1. The path to B takes us through a 0, another 0, and then a 1. So the code for B is 0, 0, 1. And for F, it's 0, 0, and 0 again. That makes the code for F 0, 0, 0. And now we have a code for each character. We can also see right here that we fulfilled the most important of Huffman's conditions. The 2 least frequent characters have codes of the same length. The codes for B and F each have a length of 3. If you can't get this to work when you do it yourself, you screwed up somewhere. And now to encode the message, all we have to do is replace each character with its code. Here's what that looks like. If we assume 8-bit encoding for each character in our regular message, the message would take up 80 bits of memory. But our coded message takes up only 19 bits. So we've just used Huffman coding to compress our message without any loss of data. If you're wondering why we don't just use a shorter arbitrary code like 1 for A, 0 for E, 0, 1 for B, and 10 for F, you should check out our video on prefix codes. Don't want to give away too much, but basically, it ain't gonna work. Huffman coding can also be used for images, by the way. First, you see how many pixels there are of each color. Then we calculate the probability of each one and build a Huffman tree. This way, you don't need to put in all the pixels, just the code for each color. So in this case, for example, yellow would have a probability of 0.5, blue 0.3, green 0.1, and pink has 0.12. Huffman coding is used to compress images in formats like PNG. Okay, so what do you need to remember today? Huffman coding is a method of lossless data compression. It works by building a tree from the bottom up and giving each character a code. The 2 characters with the lowest probability always have codes of the same length. Want to learn more methods? Or maybe just kill some time? Then check out the next video now!